Hello everybody. Today we're going to be completing and talking about notes 5D.1. Now, unit 5D, that's the last of our unit 5s. 5D is all about cubic and cube roots. We're going to talk about graphing them and then solving them. This is only a 3-day unit and then you'll take a quiz at the end. So, let's get started on attributes and transformations of cubic functions. Before we actually talk about moving the cubic function up, down, left, right, stretching, shrinking, reflecting, all that good stuff, let's review the cubic parent function. So, the cubic parent function is y equals x cubed. And if you remember back from when we made you memorize the 6 parent functions, this was one of them, and it had a parent function table of -2, -1, 0, 1, and 2, -8, -1, 0, 1, and 8. So that when we graph the function, it looks like that. Let's talk about domain and range. Now, even though it looks like it's going to eventually be going straight up and straight down, this truly isn't the case. It's still going across the entire x-axis. Okay, so therefore our domain is -infinity to infinity. So again, even though it looks like, hey, it's going to stop and just go straight up or straight down, that's not the case. It's really going up and to the right, down and to the left. So that's how we get the domain of -infinity to infinity. The range is actually -infinity to infinity as well, because it keeps going up and it keeps going down to -infinity. X and Y intercept we're all familiar with. This is where we cross the x-axis. So the x-intercept is 0, 0, and the y-intercept is also 0, 0. So, that it won't always be 0, 0, because once we start moving the graph up, down, left, and right, that will change. But for the parent function, these are our x and y intercepts. Now, the cool thing about this lesson is you've practically already done all of it before. And that's because the process hasn't changed of moving it up, down, left, and right. That hasn't changed. It's just same idea, new parent function. Okay, so like we talked about on the last slide, nothing has really changed about this chart except for the function at the top. So if you look, this is the same table we have given you each and every time. Now, b and h are inside the function that's being cubed. Therefore, they affect the x value. And remember, it's always opposite day inside the function. Now, a and k are outside the function, so they affect the y's, and you take them at face value. Now, remember, PEMDAS says you multiply before you add or subtract, and it doesn't matter what you do to this function, stretch it, shrink it, move it left, move it right, move it up, move it down, your domain and range will always be -infinity to +infinity. And we remember the x-intercept is where y equals 0, and the y-intercept is where x equals 0. So again, like I keep saying, nothing has changed except the parent function. Let's look at example 1. We're just going to jump right in there. So we have y equals 1/2 times x plus 2 quantity cubed plus 4. Let's talk about that transformation. That x plus 2, that means we're actually going left 2. The 4 means up 4. And the 1/2, since it's on the outside, that means it's a vertical shrink of 1/2. There's the description of your transformation. Now, we start with the parent function. Always start with the parent function. And we're going to create our new table. And we're going to say, okay, well, how do we go from old x's to new x's? So there is no b value. I mean, it's 1, but no b value that will really change our x's. So really, it's just x plus 2. So remember, inside that parentheses, it's opposite day. So opposite of adding 2 is subtracting 2. So negative 2 minus 2, negative 4. Negative 1 minus 2, negative 3. 0 minus 2, negative 2. 1 minus 2, negative 1. And 2 minus 2 is 0. Now, how do we go from old y's to new y's? Well, that's the a and the k value. So we're going to multiply by a half and then add 4. And we get the following value. So for example, negative 8 times 1/2 is negative 4. Negative 4 plus 4 is 0. Negative 1 times 1/2 is negative 1/2 plus 4, 3.5, or 3 and 1/2. So now we graph these on our graph, connect the dots. And that's our graph. That's the graph of y equals 1/2 times x plus 2 cubed plus 4. Now let's look at the domain. Again, the domain is negative infinity to infinity. That doesn't change. Same with the range. The range is negative infinity to infinity as well. Now let's look at this interval. It says over what interval of the domain, so remember your domain is the x's, is the function, that's your y values. So over what interval of the domain is the function increasing? Well, when you read your graph from left to right, this function is constantly increasing. So it doesn't really have a decreasing place. It's consistently increasing. So therefore, we can say it's increasing over the entire domain, which is negative infinity to infinity. Now, if that 1/2 had been negative, if it had been negative, it's not, but if it had been, then that would reflect our graph over the x-axis, and instead of being an increasing interval, it would be a decreasing interval. That's really the only thing. So if a is negative, it's going to be a decreasing interval versus an increasing interval. Let's look at max and min over an interval. So if I ask you to find the max and min over the interval of negative 6 to 4, this is where we have left and right, and we know we have to do f of L, f of H, f of R. So my H value from the equation above is negative 2. So I want to see the f of L, f of H, f of R step, and I want to see where you change L to negative 6, H to negative 2, R to 4. Those two steps I want to see. However, these next two steps where you plug it in, I'm going to be honest, if you can do that in your head, you don't need to show these two steps that I just flashed up. I just put them up there on the screen so that way you can see where I get the values if you're having trouble seeing that. But basically what you're doing is you're plugging negative 6 in. Negative 6 plus 2 is negative 4. Negative 4 cubed is negative 64. Half of negative 64 is negative 32. Negative 32 plus 4 is 28. And same with the remaining values. So we have negative 28, 4, and 112 when we evaluate at these three specific x values. Now, if negative 2 had not been in between negative 6 and 4, obviously we wouldn't have calculated them. But for the minimum value, that's negative 28. So the way we write that is f of negative 6 equals negative 28. And that's your minimum. Now your maximum is 112. So the way we write that is f of 4 equals 112. Now let's pause right here for a moment. Let's stop and think. This graph is constantly increasing. So your max or min will never truly be at the h value. So for cubic functions, when we ask you to find the max and min over an interval, you don't have to really worry about the h value unless you just want to, do that because that's ingrained in your memory that you have to do f of L, f of H, f of R. But like I said, for cubic functions, you only really need to do f of L and f of R because your max and min are going to come from those endpoints of that interval. Now, let's talk about finding the x and y intercept. So the x-intercept, if you remember, is where y equals 0. So I substitute 0 for y and just solve it. Now, think back to, I believe, day 4 in Unit 5C, where we solved these. We solved functions like these. So this is really not a new concept for us. So here we go. Your goal is still to get the parentheses cubed isolated. So the first thing we're going to do is we're going to subtract 4. That gets me -4 is 1/2 times x plus 2 cubed. Now, to get rid of the 1/2, we're going to multiply both sides by 2. So 2 times -4 is -8, and that gets me -8 is x plus 2 cubed. Now, to undo cubing something, we take the cube root. So the cube root of -8 is -2, and the cube root of x plus 2 cubed is x plus 2. We then subtract 2, and we get x is -4. But wait, we can't leave it like this. This type of answer will not get you full credit. To get full credit, you've actually got to write the intercept as a coordinate point, which would be -4, 0. Now, for the y-intercept, remember that's where x is 0. So 0 plus 2 is 2. 2 cubed is 8. Half of 8 is 4. 4 plus 4 is 8. So 0, 8 is our y-intercept. Now I know you're probably thinking, why do we have to show our work for solving the x and y-intercept if we could just get it off the graph or we could get it off the table? Well, if your graph is wrong or your table is wrong, then that's going to force your x and y intercepts. It's also a way to check yourself. And quite frankly, if you just want to know, on the quiz that you're going to be taking next week, we make you solve for the x and y intercept algebraically. So it's probably a good idea that you need to know how. Okay, and then sometimes it's not always going to be as a pretty point from the graph or the table. So it's always good practice to know how to solve it algebraically. And plus, again, you're going to need to demonstrate that skill on the quiz. So it's good to know. All right, finally moving on to a new example. Example 2. I want you to write the equation of a cubic function that has been reflected across the x-axis, vertically stretched by a factor of 2, translated right 3, and up 1. So, reflection across the x-axis means my a is going to be negative. Vertically stretched by a factor of 2, that also means my a value. So my a value is going to be -2. Right 3, that means inside my parentheses, I'm going to have an x minus 3 quantity cubed. And up 1 means my k value is going to be 1. So your equation looks like this. Y equals, don't forget the y equals, -2 times x minus 3 quantity cubed plus 1. And that's it. That's as hard as that example gets. Okay, here is a good problem for you to try on your own. So what I would recommend doing at this point is pausing the video, using the function above, find these 7 items or complete these 7 items. Then when you're ready to check your work, hit play and you'll see the answers. Okay, so let's look at our answers. There's the answers and there's the graph. Let's look at example 4. Given the graph below, write the equation from the graph. This gives us flashbacks to when we did this as a quadratic. So remember, when we did this with a quadratic, we had to use h and k, x and y, and then we resolved for a, and then once we got our a value, we used a, h, and k to write the equation. This is the same process, except instead of using a quadratic, we're now going to use a cubic. Okay? And also, to just FYI, when we ask you to write the equation from the graph, okay, when we ask you to write the equation from the graph, we're never going to require a b value. Okay, so if we ever ask you to write the equation from the graph on a quiz, a test, whatever, just know there's not going to be, excuse me, bad grammar. There's not going to be any B value. Okay, it's just going to be A, H, and K. So let's talk about what we know. We know HK, that's the center point. That's the initial point, if you will, I guess. That's 0, 4 in this case. The next thing we know is they give us a point on the graph, 1, 6. So 0, 4 is the HK, 1, 6 is your XY. So we're going to plug H and K, X and Y, into Y equals A times X minus H cubed plus K. And then we're going to solve for A. So here I've plugged in all my values. And now I just start calculating. Now 1 minus 0 is 1. And 1 cubed is 1. Now here is where everybody makes a mistake if they're not paying attention. If you're not paying attention, you will say 1 cubed is 1 plus 4 is 5. No, no, no. The minute you cube that value next to A, because that's A times that value, then plus 4. So the minute you cube that value, which in this case is 1, you need to pull it up to the front of A. That way you're not tempted. That way you are not tempted to add it to the 4. Okay, now we solve. Well, I subtract 4. 1 times A is A. So I have my A value. I have my H and K. So I'm going to use A, H, and K. I'm going to leave X and Y as variables, and I'm going to write my equation. So I get Y equals 2 times X minus 0 cubed plus 4, or Y equals 2X cubed plus 4. Since my H was 0, it really does not matter which form you use. Okay, so example 5, last example. Y equals 1/2 times 1/3 X plus 1 quantity cubed plus 1. Now, immediately, the very first thing I see is, oh my gosh, we've got a B value other than 1. So the first thing we need to do there is we need to factor out that B. Now, when we factor out the B, notice that it's still in the parentheses cubed. It's just it's a parentheses now inside of a parentheses. So, and you're probably thinking, well, that doesn't make sense. I factored out a 1/3 and I got a 3. But think about it. If you were to redistribute that 1/3 to put it back together, you'd have 1/3 X, and then 1/3 times 3 would be 1. So when you're factoring out a fraction, just understand that it's really like 1 divided by 1/3, which is really 1 times 3. So if you were another way to think about it, you'd have to go, okay, 1/3 times what gives me 1? So the what goes in where that 3 is. Okay, so we have A is 1/2, B 1/3, H -3, K 1. So now we're ready to graph. We start with our parent function table, and I have to go from old x's to new x's. So the B and the H, they affect the x's. So I have to say, okay, it's like, remember PEMDAS, multiplication before addition or subtraction. So I'm multiplying by 1/3. Well, what's opposite of multiplying by 1/3? Division by 1/3, but wait a minute. Division by 1/3 is the same as just plain old multiplying by 3. So if your B is a fraction, to get rid of it, or to go from old x's to new x's, multiply by the reciprocal. So I'm going to multiply by 3 and then subtract 3. Okay, now to go from old y's to new y's, I'm going to multiply by 1/2 and then add 1. Because remember, A and K affects the y value. So we're going to multiply by 1/2 and we're going to add 1. Now we graph the points and connect the dots. And that's it. That's all there is to it. Here is a kitty. It tells us we're done. All right. So this is the end of the lesson. Your homework is worksheet 5D.1. It's in the it's right below this video in Canvas. So that's your homework, 5D.1. All right. If you have any questions, come see me or another Algebra 2 Pre-AP IB teacher. Have a great day. Bye, guys.